Hey guys, so this is the section 4.5 and 4.6 video. We are going to start talking about SSS, SAS, ASA, and AAS. It's a lot of letters, right? And the order does matter, so we need to make sure we're careful here. Before we start, I just want to remind us, we want to talk about this real quick. In the last section, we talked about having congruent triangles, right? So we proved that triangles were congruent by showing that all 6 pairs of corresponding parts were congruent. Right? So if we looked at our last section, we had all of the angles marked congruent and all of the sides marked congruent. So I'm going to flip back to this page just real quick for us. We had all 3 angles, all 3 sides, and so we were able to say that the triangles are congruent, right? Well, having all 6 sets of corresponding sides or angles congruent, that's annoying, right? So we want some shortcuts here. So that's what we're actually going to talk about. So if we have this first one here, we're going to talk about is side, 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 and we abbreviate it with just SSS. Makes sense, right? Pretty easy abbreviation there. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. Okay, so take a look at that picture that we have there. We have triangle ABC, and then we have triangle DEF. And we know what the sides are, right? AB is 4 centimeters, BC is 6, AC is 7, DE is 6 centimeters, DF is 4, and FE is 7. So those all match up, don't they? So I'm going to put some tick marks here so that we can kind of see really what's going on. So AB is 4 centimeters. I'm going to put 1 tick mark. And I want to find its corresponding side over here, so DF. Okay, so those ones are congruent. And then if we look, BC is 6 and DE is 6. So I'm going to put 2 tick marks on those. And then AC, I'm just going to put a circle on it. And that's congruent to EF, because that is also 7 centimeters. So when we look at this, whether we knew the exact lengths or whether we just had those tick marks, we would be able to say that those triangles are congruent by side, side, side. Okay, so our conclusion is going to be that the 2 triangles are congruent. So I'm going to start with triangle ABC. And remember, we were talking about this order is going to be really important, right? So triangle ABC is going to be congruent to, if I go ABC, I'm going to want to make sure that I go FDE. Okay, so ABC, I started with 1 tick mark, 2 tick marks, and then my circle. So 1 tick mark, 2 tick marks, and then my circle. I go in the exact same order. Okay? The order is going to be super important here. All right, before we talk about the next shortcut, we have to talk about this included angle. Okay, so an angle formed by 2 adjacent sides of a polygon is called an included angle. So if we look here at this picture, AB is one side of a polygon, BC is another side of a polygon. This one happens to be a triangle, right? But either way, we've got 2 sides of a polygon, and they meet together and they form this angle B. So angle B is the included angle between sides AB and BC. All right, so we need to be able to identify included angles because that's what we're going to need for our next shortcut. So our next shortcut is side angle side, which we abbreviate SAS, side angle side. All right, if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. Okay, so essentially we've got two sides and an angle that are congruent. And the thing about this though is that that angle has to be included in between the two of them. So AB I'm going to highlight with orange because it's got one tick mark, and FE, that's got one tick mark also. So I'm going to highlight that with my orange. And then let's do this green. AC right here has got two tick marks, and DE also has two tick marks. So when I look at that, my green and my orange are meeting at exactly one angle, right? And they're meeting at, in this case, this one over here is angle A, and this one over here is angle D. Angle A is included in between these two sides, and angle E is included in between these two sides. They're all right in a row, right? This one I've got a side, and my angles that I just colored in, those are my A's. And my other side right there, they're all right in a row. They touch each other. 1, 2, 3. That's my SAS, my side angle side. So my conclusion here is going to be that the two triangles are congruent. So if I start here with triangle, let's start with BAC. Okay, it doesn't necessarily matter what order I started in on the first one, but that determines my order for the second one. So BAC, I'm going to have to go FED for my second triangle. Okay. The order is very important when we're naming our triangles. It's also very important that that angle is in between my two sides. It has to be that included angle. Otherwise, it's not side angle side. We can't use it. Okay. Now, we've got to talk about this included side. Okay. So just like an included angle, it's very similar. Okay. We're now going to talk about included side. So the common side of two consecutive angles in a polygon. So consecutive means right next to each other, all right? So P and Q are next to each other because I can go from one to the other without hitting another angle in between, right? I mean, I could go the other way and hit R, but in a triangle, we can go this way too, okay? So when we look at angle P, if I draw the start of angle P and I draw the start of angle Q, the side that they share is called their included side. So PQ is the included side of angle P and angle Q. Okay, and that's going to be important for our next shortcut, which is angle side angle. All right, or ASA. Again, order is going to be important here. Okay, if we have two angles and the included side of one triangle, if they're congruent to two angles and the included side of another triangle, then our two triangles are congruent. Okay, so essentially if we've got two consecutive angles, their included side, if we've got those marked congruent, then we get to use this shortcut ASA. Okay, so I'm going to highlight angle A in green. That's congruent to angle D. Those both had one little arc mark. Angle C has two arc marks. So does angle F. So those are congruent to each other. And if we look, AC is the shared side between those two angles. DF is the shared side between those two angles. And they both have a tick mark to show that they are congruent. Okay, so you know how we did all that practice with the markings and stuff? That's why we did that, because we need to be able to pull what these marks mean, right? So we can get then that we've got angle side angle. They're all right in a row again. A, S, A. A, S, A. Okay, 1, 2, 3, all right in a row. I don't have to pick up my pencil to go from one to the other. Okay, so our conclusion is going to be that triangle, let's go ACB is congruent to triangle. So if I went 1 across the included side and then to the 2, I'd have to go DFE for my second triangle. Okay, so ACB, triangle ACB is congruent to triangle DFE. And we have one more trick that we can use to prove that two triangles are congruent. So we've done side, 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 or SSS. We've done side, angle, side, SAS. And we've done angle, side, angle, ASA. Now we have this third one, angle, angle, side. So AAS. Well, hold up, because this one up here was angle, side, angle. So that was two angles and a side. This one is now angle, angle, side. So it's still two angles and a side. But if you notice, the order is different, right? That's why I said order is going to be really important here. So we need to see what this one looks like. So if we have two angles and a non-included side of one triangle, and they are congruent to the corresponding angles and non-included side of another triangle, then the triangles are congruent. Okay, so the big thing with ASA up here was that we had the included sides congruent. On this one, we're saying that the non-included sides are congruent. So let's take a look at that diagram and see what's really happening here. I'll zoom in a little bit. So angle G is right here. It's got one arc mark, and that's angle K right here. That's one arc mark. So I'm going to put an A there, because we know we've got at least one angle, right? And then angle J, that's got two arc marks. And angle M has two arc marks. Sorry, I put a tick mark through there. I didn't mean to. But angle J and angle M are congruent to each other. So cool, there's my other angles, right? But then look at the sides that are marked congruent. I've got HJ marked congruent to LM. So I'm going to put an S there to show that that's my side. But take a look at that. LM, let's look at this triangle first. LM is not included between my two angles. And look at this one. HJ, not included between my two angles. Because here's an angle, and then I skip this side to get to my other angle. Then I have my congruent side. Same thing here. I've got an angle, and I skip this side to get to my angle, and then I have my third side. So these ones are congruent by AAS. This is angle, angle, side. That's the difference between the two, between AAS and ASA. Okay? We're going to do lots of practice with identifying the two, okay? But please, please, please write down any questions that you have. We'll talk about them on Monday when you guys come in, okay? But let's name our triangles, okay? So triangle, and I'm going to go G, J, H. Congruent to triangle. Okay, well, if I start at G, I know for sure I have to start at K, because those are my congruent ones, right? And then I went to J. Well, J is congruent to M, so then I must be going KML. Okay, so triangle GJH is congruent to triangle KML. I know there was a lot of letters in there, guys, okay, but the important part here is that we are going to be talking a lot about these different methods. So we had side, 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 which was our SSS. We had side, angle, side. We had angle, side, angle, and we had angle, angle, side. These are our 4 main ways to prove that 2 triangles are congruent, okay? The order does matter, especially with these two, okay? We're going to talk a lot about it. Write down any questions that you have, and I will see you guys on Monday. Have a great weekend. Bye!